Assalamualaikum and hello, my name is Fatih Srina binti Syarul Azmi. We are from UniKL MFI. We present to you about our project IoT on Robotic Well under subject IIoT FSB 20203 Introduction to Industrial Information Technology. Before we start, this is my group mate Al-Baziz Hafram bin Azizan, Wan Muhammad Izzat bin Wan Syafi'i, Muhammad Nur Hakimi bin Muhammad Nordin and Fakrida bin Faizal. Robotic welding automate the welding process by using robot that perform and handle the welding based on the program that can be modified to meet the project needs. Manufacturing feature less in connectivity. It will only be a matter of time before high connectivity devices become commonplace in production. And with good cost, the industrial Internet of Thing IIoT, or to put it another way, a highly linked environment where equipment can communicate with one another, operators and technicians. The objective of this project is one of it is to reduce the manually checking time needed for maintenance and service. Second is to increase the accuracy of data in system automatically, and lastly, to enhance safety in the workplace for workers and machine.
Process and activity offered by the proposed system. Firstly, a basic robotic arc welding system consists of two subsystems: welding equipment that deliver energy from the welding power source to the workplace, and the robot that provide relative position of the heat source and the workpiece. Second, traditionally, general-purpose industrial robot using arc welding torch as an effector have been used. Thirdly, many robot manufacturers has lately produced smaller and less costly arc welding robots. Fourth, workpiece manipulator are widely used as a part of a robotized system in a manufacturing setting. And lastly, the control of a manipulator is frequently combined with that of the robot, allowing the two systems to be controlled synchronized and simultaneously. View of user interface. The user interface is the point at which people and machine interact, and these designs are frequently envisioned independently, such as a mechanical head and a table-sized screen, or a screen with an avatar's face and another for the graphical user interface. Finally, when the avatar and graphical user interface are shown on the same screen, the visual and interactive and aspect compete for the user attention, increasing the complexity and influencing the user opinion of the robotic system. In other words, because robots exactly duplicate the same weld rods every cycle, the component to be welded must be kept in the same right position each cycle to achieve repeatable, accurate welding automation. Furthermore, many businesses prefer to keep their automation equipment editable. When it comes to the feature changeover, it's helpful to convince about it as one component of a bigger system. The design must also prepare for the storage and retrieval of features when they are not in use to achieve maximum efficiency in welding automation. And automated featuring and changeover may be programmed to read the barcode on the component, shift the correct feature into place, check the correct piece are being welded, and finish the weld. Thank you.
Justification on IoT integration. Why do we have to integrate IoT to manage the machines? The main reason we apply IoT to manage the machines are predictive maintenance. Predictive maintenance is the primary reason for using IoT to manage the machines, rather than performing periodic calendar-based inspections and component replacements. Predictive approaches monitor equipment for potential problems and notify you when a part replacement is required. Failure data from numerous sources can be captured, pulled, and analyzed in real time within the cloud when equipment fails. The system can take repair alternatives automatically and, if necessary, recommend measures to the technician. By this, we can save a lot of time and more efficient. The last reason on why we have to integrate IoT to manage the machines is less error since the system is more precise than human workmanship. The system can automatically calculate availability, reliability, and the other key performance indicators such as mean time between failures and mean time to repair, and feed them into reporting dashboards. This eliminates the need for humans to record all downtime and resulting in more precise data.
Okay, next we move on 2.1 system overview. This part we have three main components involved. First we have Arduino Uno. Second we have ESP826601 Wi-Fi modular, and the last one is gas leak sensor. Alright, for this project we use Arduino Uno to read or collect the data, which is the getter from the welding machine, and send to the technician for maintenance. Next, for the ESP826601 Wi-Fi modular, they allow the microcontroller to access the Wi-Fi network, so the data will be transferred to the IoT cloud and bring an ideal way to monitor gas leak by simply using cell phone. Alright, the last one is gas leak sensor. This component works to detect any leak on welding machine. So the detector will make sound and alarm to operator in the area where the leak is occurring, and then giving them information to leave or make a maintenance. Okay, next we move to 2.2 software requirement. In this project we use two software, which is Arduino IDE and ThinkSpeak Server. Arduino IDE works well with Arduino Uno, as it is where the coding and instruction will be written. And the second is ThinkSpeak Server. ThinkSpeak Server is one open platform service which allow the user to aggregate, visualize, and analyze the live data stream in the cloud. Data that has been received will be uploaded in ThinkSpeak, then allow the user to monitor from any device anywhere. Alright, as you can see, this is our flowchart. When the machine turns on, the gas pressure reading will be taken. If abnormal, notification will be sent to the mobile phone to check maintenance. Then the maintenance duration will be checked if it has been exceeded. Notification will be sent for it if the total duration is more than 6 months.
Business opportunity to market the system. Hundreds of machines are now used in companies for various procedures, including as cutting, forging, melting, extruding, and a lot more. All of these industrial operations must be monitored 24 hours a day, 7 days a week, employing the Internet of Things sensor. The gigabytes of data produced by these machines are directly stored in the cloud. By using artificial intelligence, this data is further examined to identify even the tiniest deviation in the production process, such as machine vibration, temperature, pressure, and so on. And you may predict a machine's future failure point with the use of historical data before it breakdowns, and it will reducing downtime, unforeseen costs, and lost production. Our target user and customer for this project is purposely for companies that commonly use and own the machine itself. For example, I give is Akademi Bidaan Malaysia Selangor Sdn Bhd, TWF Technology Southeast Asia Sdn Bhd, and our own university, which is University Kuala Lumpur Malaysia France Institute itself. That's all from me. Thank you.